Hey everyone, in this video our objective is to address old Regents questions related to naming compounds. So let's begin. What is the correct name of the compound with the formula NH4NO2? Well, the first thing we must consider is this. Let's inspect that. NH4NO2. Now, if you see more than two different elements in a compound, please, at this level of chemistry, be suspicious that a polyatomic ion is present. So I see nitrogen, I see hydrogen, and I see oxygen. I do see three different elements. So I am suspicious of a polyatomic ion. And to investigate that further, we take a look at Table E. Now, Table E shows me a whole bunch of different polyatomic ions. They do not need to be memorized. So, NH4. Do I see NH4? Well, there's NH4. NH4 is right here. Ammonium. And NO2. NO2 is right there. And I see nitrite. So, I'm looking for the formula, or the name, ammonium nitrite. And ammonia nitrite, ammonia nitrate, ammonium nitrite. There it is. So question 2. What is the correct name for the compound with the formula CrPO4? Now I do see 1, 2, 3 different elements. So I need to be suspicious of a polyatomic ion being present. So is it CrP or is it going to be PO4? Let's inspect. If we take a look at our Table E, our selected polyatomic ions, and we were to look for CrP, look as long as you want, you will not find it. But what we will find is PO4. And there it is. Now, I also want to take note of this 3 minus. Okay, because part of the question will require it. So I'm just going to write it down here. 3 minus. Alright, so we are looking for phosphate. So A says chromium 2 phosphate. B, chromium 3 phosphate. C and D both say phosphide, so let's just get rid of those because they can't be true. And now we are looking for either chromium 2 or chromium 3 phosphate. Now I do know, in inspecting this once again, that I have 1 chromium for every 1 phosphate. And let me show you why that is important. Because it is a 3 minus. Okay, so we have a 3 minus for the phosphate. And to make it easier on the eye, let me put some brackets around here. So we have 1 chromium for every 1 phosphate. So what that must mean is I must have a 3 plus charge here. So that in fact, while chromium is losing 3 electrons, phosphate is acquiring 3 electrons. That's why we have the negative 3 charge. Now take a look at this. I got this from our periodic table. And this periodic table is showing that chromium could be a +2, a +3, or a +6. So as evidence of this +3, we are looking for the chromium that can acquire a +3 charge. Rolling back to our choices. We have choice A that says chromium 2. That would mean that it's using the +2 charge. Cannot be. And choice B says chromium 3 phosphate, which means it is using the +3 charge. The answer is 2. Question 3. What is the name for NaClO3? Now be careful, that's not Ci, that is Cl. And as I did with the previous question, I wrote it out, and I am suspicious of a polyatomic ion being present because I have 1, 2, 3 different elements. So I'm curious, is it NaCl or is it ClO3? And when we inspect, we will find out that it is in fact, where is it? ClO3 right here. And that's called chlorate. So we are looking for something with the word chlorate in it. And choice 1 says chlorite. No. C says chlorate. Yes. B says chloride. And D says perchlorate. So we already know that it is choice C. It is sodium chlorate. Question 4. A correct name for N2O3 is, well, we have to identify that this is the type of compound that has a nonmetal combining with another nonmetal. It is a covalent compound known as a molecule. So we have to use a naming system that has prefixes. Now, how many nitrogens do we have? 2. So the prefix is di. We would call this dinitrogen. And how many oxygens? 3. Triox, and we modify the end with an IDE ending, trioxide. So this is called dinitrogen trioxide. Question 5 has this statement. A scientist in a chemistry laboratory determined the molecular formulas for 2 compounds containing nitrogen and oxygen to be NO2 and N2O5. Write the IUPAC name for the compounds. Don't get disturbed by this name, it just means name them. Okay, and once again, just like the previous, we notice that we have nitrogens and oxygens, both nonmetals. It's covalently bonded, so we need to use the system that uses the prefixes. So our first compound, let's draw that one in red. How many nitrogens do we have? But 1. We do not need to know the prefixes or use the prefix for that. It is called nitrogen. How many oxygens? We have 2. It's dioxide. Now in blue, we'll note the other one. How many nitrogens do we have? We've got 2. So this is dinitrogen. And how many oxygens? This time, 5. 5 is pentaoxide. Question 6. What is the correct formula for potassium hydride? Hydride. That kind of sounds kind of fancy, and I know that I've seen something similar to hydride on the polyatomic ions list, so let's take a look. Hydride. No. Hydroxide. But that's not hydrogen. Nope, I am mistaken. It's not hydroxide. So OH is not the case. Oh, look at here. Let me grab a pen. Look at this. OH? No, that's hydroxide. And again, OH here, that's hydroxide. So hydride must mean it's hydrogen, just the ending was changed. So is it KH or KH2? Well, at this time we now need to inspect whether or not, what the likely charges would be for these. Now potassium, let's take a look at potassium, see what its charge would be, and oxygen, hydrogen I should say, also. And they are right here. Potassium is +1, and hydrogen could be a -1. So let's put that in and see what makes sense. Grab a green pen this time. This is +1, +1, -1, -1, And if we do the crisscross, which one of these works? This would be a 1 drop down to here and a 1 drop down to here. Looks good. 1 drop down to, that says 2. It doesn't fit. It cannot be this one. So the answer for number 6 must be A. And last, question 7. What is the correct formula for iron 2 bromide? Focus on that 2, because that 2 is telling me something very important. It is telling me that the iron is the +2 form of iron. And bromide. What is the likely ion that's going to form from bromine? Let's take a look at its oxidation number. Well, when it ionizes so that it can bond with iron, it is likely to become this -1. So let's go ahead and put -1 in. -1. And let's drop the 1 down to here. Drop the 2 down to here. And let's rewrite it. And I'm rewriting it because we never use the 1s in the subscripts. Br2. Now that is iron 2 bromide. There's your answer.